Welcome back to the HP Clock Boards Repairathon. After we unleashed our improvised bubble LED clock tester and the HP Logic Analyzer, we finally got close to 100% success on Halloween night in repairing our 12 faulty boards. We have only 2 recalcitrant boards remaining at yellow. So let's see if we can get over the hump and, like Mr. Fancy Pants, start playing with our clock-equipped 9825. So hopefully today this will be the last hooray for our clock cards. I have 2 remaining ones that are yellow that we want to bring to green. And they both have a problem with one of the interface ICs to the clock chip. And on top of that, we have this one lives on a borrowed ROM because its ROM was bad, so we need to change it with a PROM. One of the remaining bad boards is the one that caused the magic smoke release in episode 3. But it turns out the smoke was my own darn fault and was fortunately an easy repair once I figured it out. When we tried it again in episode 4, another fault showed up. It could not read the clock time. I quickly traced it to a malfunctioning gate in the clock chip to nanoprocessor circuitry. So I tested all of these gates, and sure enough there's one that doesn't work. But that's a 1, came out as a 0. So unfortunately I don't have that IC on hand, so I have to order it and replace it. Actually, this early CMOS 3-state buffer was no longer available in a DIP package. Fortunately, Carl had one in his vintage chip collection, so I just desoldered the old one and replaced it with the new old one. Yep, got it. Here we go. Alright. Yeah, let's see if that fixed it. Nothing goes. 1, 2, 3. Okay. It's trying to read the chip. Do I have error 13, error 16, or error 32? Error 16. That's good. Set the time. And I should set the time over here. And see if it gets stuck this time. Okay. Let's see if we can read the time. Can read it. Any errors? No. Okay. We repaired it. This one, after many adventures and a short that wasn't really a short, we found that it was this circuit that was bad. So this is bad to green with just one bad circuit. Let's try to see if we can get our last one going. The final board we will be trying to repair has been the most frustrating of them all, having all kinds of unusual and non-reproducible symptoms. At first, it would stop working as soon as it was powered. It goes off, and it comes back. If I turn the thing on longer, it goes off. And takes even longer to reappear. This odd behavior eventually went away when we swapped the 32 kHz crystal. There you go, it stays. And yes, it's reading the time. Is it? But the rejoicing was short, as it then got confused when trying to set up the time and got stuck somehow. After a long hunt, we eventually found that the set button line was at a weird voltage, probably from being cross-wired to something else. We immediately suspected a pseudo-short caused by the battery corrosion and the blue residue it left behind. So we cleaned the board with vinegar and a good brushing. sure was something there. Now our setline appeared fixed, but something else went wrong. The nanoprocessor stopped working altogether. So out of despair, we put the nanoprocessor in another board and it checked good, so we put it back in, and then miraculously, as we were about to give up, the board started working perfectly. So we give it the green sticker of approval and used it as our reference clock board in episode 4 while working on the interface board. Until it failed again. Some more news on my the former Vinegar board that re-failed, and this time it seems to be a different problem. Looking at it at the end of last episode, it still looked like a failure on the set line, but now of a different kind. Instead of settling at a weird intermediate voltage, it now properly assumed nice logic levels, but was unstable when transitioning. So it should only change state when there is a latch. That is not normal, it's unstable. So we naturally suspected a failure of the latch gate that drove that signal. Fortunately, Carl also had this chip in his collection. Okay, and on this one we suspect it's this chip U7, that's the one that presses the button. Okay, come on. Get out. Alright. Alright, let's see if that repaired it. We'll see if we revive the board that died twice. Yeah, it's trying to read the clock. Alright, and let's see if it got back with air 16. It did. Let's try to set it. Let's see. It does its little dance here. That might not have worked. It looked better this time, but no cigar. It did not succeed setting up the clock time, and the processor reported an error 48 at the end. Okay, end of infinite loop. Read. Yeah, it couldn't set the time. It probably has an error 32 or 48. 48, yeah. So we have sure fixed something. None of the button presses are clean. They don't have this, you know, the multiple bounces that we had before. Actually, I think the problem is better, but it's still there. If you watch the green line, you see it's still cross-coupled to something. It had some wiggles in it. So the new circuit made it better, but there is still some green dust somewhere that's coupling two traces. And I have vinegared it twice or 3 times. It's deep inside the board. I don't know if we can ever get it to work on this one. I think I have an inkling of what's going wrong because we are almost there. We should set it to month 6, day 5, IR 4, minutes 3 and seconds 2. And after it fails, there is something in the clock that's almost right. It's 4, that's correct. 15, that's wrong, it should be 5. So it got the digits, the 10th digits of the minute wrong. 6 is correct, that's the month. 5, that's the date, that's correct. So it just got that digit wrong, the second digit. I think that's the one it cannot read, and that's why it cannot set neither the minutes nor the seconds. And it lucked out on the day because it doesn't have a second digit. And I have taken a look at the gates that read the digits, and it's fine. so no problem there. Then eventually I went to the logic analyzer and tried to figure out what the processor was doing when it got to the fault. I can catch when it sets the error, the clock hardware error. I can see that it fails here. So it reads a segment combination it can't decode, and then you look where it came from, and this is when bit 1 here is a test for which digit, and this is digit 2. So what I was saying is correct, it can't figure out digit 2. And then you trace the code back, and at some point it tries to read digit 0 and calls the decode segment, and it's fine with that. So it's something really silly that some signal, I bet you some signal from digit 2 leaks into the segments and gives a wrong reading only in that configuration. This is going to be impossible to find. That's another of these Blue Desk problems, creating alternate paths that shouldn't exist. Okay, I think I found the smoking gun. So I was looking at all my segment here, and this one looked okay. But now I'm on those three. This is SG, SF, SE, respectively, blue, green, and yellow. And first, something that you note is that the blue is at 0 when it's at rest, and it should be at 5 volts like the other ones. And then let me give it a little reset. So it tries to read the numbers. Look at that. It had half half logical levels. Let's try again. Come on. Look at this. So that's my problem. Is that this guy is cross-coupled with something else, and I bet you it is cross-coupled with digit 2 or something. So I have now moved over here, checking this transistor. I'm checking a segment that works, where I'm going from 11 input to 12 output, and this is the kind of signal I have. Make it wiggle a little bit. This is the input, this is the output, and it's inverting perfectly well. So that's a working one. And now I am going to move to my faulty line, and here we go. And what the heck, you can tell that, well, the signal a little bit goes through, but it's mostly cross-connected with something completely different that drives it from 0 to 5, and then the little poor transistor is trying to get it down, but it can't because it's overwhelmed with something else. So that line is completely cross-connected, and I've looked at the board, I cannot find from where. So basically this fellow is connected to something completely different. I have no idea what it is. Maybe I'll look for a signal that looks the same. Okay, and I think I've found what it's cross-connected to. So that's our output of the segment. That's the segment itself, that's the output, and that's the set button. And you can tell those two are following each other. There you go. It's exactly the same pattern. Actually, you can see that it's cross-connected in the other direction, right? This guy influences the set button too. So it looks like the set button, pin 10 on U7, is cross-connected to the reading of the segment 14 on U13, which must be a remnant of the issue we had before. Remember that the set button was not behaving properly, and man, this thing has gone 3 times in the vinegar, and I can still see corrosion just about everywhere, so it's just almost impossible to get rid of it. So that would be this chip. That's the one we changed, and pin 14 over here. Yay, 25 ohms. Okay, so we really ferreted our problem. The only issue is that I cannot see where this 25 ohm bridge is. It's not obvious at all. Right, so I followed the trace and there is one place where this pin comes close to that pin, and this one is loaded by a 10k resistor over here, and it's the trace that comes over here, and as you can tell it's right next to the pin it's cross connected to. So if we look at that in detail, well, that's as far as my zoom is going to go on this camera. I bet you the problem is between this pin and this trace over here. But I still could not see anything wrong with the naked eye, and under the bino I saw nothing either, at least at first. But wait, maybe there is something. Oh, now I think I see it, to the left of the trace that goes in between the IC pins. Alright, that's the money shot. Now you can see the freaking bridge clearly. Probably a remnant of the blue goo left behind after the acid vinegar etch. And of course, once I knew where it was a piece of cake to scratch it away with a dental tool. But my goodness, that thing was hard to find. So under the binocular, I went with a dental tool and scratched out the debris that was in there. Which is probably, so there was no blue death, but I think that's what was left behind after the blue death was gone. So if I go directly, on the pin itself, our pins are not cross-connected anymore. It's a relapse from the problem we had before. So visually I went after here because that's where it was blue, but it's not where it visually looks bad, it's where it actually happened. So you're never going to get it by just looking at it. I had some viewers that were dismissive of the whole process, and I'd say I spent way too much of time on the board. They would have repaired them right away just by looking at them. That's how they repair all the boards. They just look at them and redo all the solder joints. And this is balloony. There were 4 faults in that board. Do you see them? And of course you can't, right? It's impossible. It's pixies. You don't see the pixies. You need the oscilloscope. If you can feel the pixies, it's bad news. It means you're electro boom and you're feeling them and it's too late. Or if you can smell the pixies, it has released the magic smoke, so that's not good either. So that's the issue. It's not mechanical. Mechanical, you can look at it and you'll figure out what it is. If it's electrical, you have to measure it. You can't see pixies. So I'm all hooked up after scratching up what I think was the short circuit bridge. Let's try to start it up. And yes, comes up. Read 00. That should mean that it has error 16. Yeah, time not set. Let's set the time. Month 6, day 5, hour 4, minute 3, second 2, and off we go. And it's doing its little rigmarole over here. It's going through it, and you can see it got the 6, 5, 4, 3, and now it's just going to go and get the seconds exact, I think. Got it. So it knows how much time it took to set the clock and then adjust the seconds at the last thing. No errors. Read my clock. We repaired it. Alright, man. That one was a silly thing, but we finally got the better of it. So I think we're all repaired, 100%. Okay, it's time for a little celebration. That's the last one, and it's now green. So now we are good. It's all green, 100%. Except we are 1 ROM short because this ROM was totally dead, and I borrowed the ROM from another board. So I need to program a PROM instead of a mask ROM and do a little hack so it can work with the different selection logic. And we should have 6 good interfaces. Alright, the final step is to replace that dead ROM with a PROM, and I didn't have a 2716, I have a 2732, which is twice as big, which means I need to modify the file a little bit. It turns out the way it's wired, it's going to read the upper part of the 2732, so I just copied the code that I dumped and pasted it. So now I have a 32K file, and that's what we are going to burn. Okay, I'm all loaded. It's an A, so I think it's a more recent device. It should work with a 12.5 volt setting. I had problem with older device where they were 25 volts and you have to manually adjust it here. But let's just run with this, see what happens. Program. Alright. So that didn't work so well. Let's do that. Device. Program. That works a lot better. So this is actually one that requires more voltage. Alright, and it got it. So we're going to do a read. Well, it already did that, but just to be sure. Okay, so the trick, there you go. We got my AFAFAD. By now I know that's the code, and I have it doubled up at 800 AFAFAD. Okay, so I just had to adjust the voltage for my old PROM, and it was all fine. So we should have one PROM that's good to go. We'll protect it from the UV, put a sticker on it. I'll get that one. New old version of the ROM. If you remember from the previous episode, the mask ROM and the PROM are slightly different, and the select goes reverse. So to read that mask ROM with the PROM reader, I had to invert the select pin here, put it to VCC. So conversely, if I exchanged this ROM, mask ROM, by my PROM, the select has to be inverted, but it turns out it comes out of the processor, goes to the other board, and comes back in. There's just a little short. So it's probably easy to put a little inverter, and I figured out the transistor would do, and invert the signal. And that is what I have cooked up here. And what I'm going to use is one of those little transistors that's made for making logic inverter gates, so it has the resistors in it already. I only have to add the collector resistor. So if I put my little transistor, that's this fellow right here, on the back of the board, and a resistor, it should all fit. I have to cut the trace. That's right here, and I should be good. That's the final hack to make it work with a PROM. After I discovered that the C114 is not the same as an A114, and that I put the transistor the wrong way around, and that I need an input resistor not to drive this guy too much into saturation. Alright, after a little bit of monkeying around with the circuit, I made it work. These transistors are convenient, but darn, they are slow, so I had to add a resistor not to drive it into saturation, and it's just barely enough. But, you know, it works. It reads the clock. It has 0 error, so it works with the new ROM, with my little modification. So we'll consider that all my cars are repaired, including the one that works with a fake ROM. Alright. Alright, we did it! We repaired all of our boards and all of our modules. So now it's just a question of calibrating them to perfection and reassemble them, and then we can play. So don't miss the next episode where we'll finally get to play with our 9825 like the Magic Pants dude. We'll even get to don our very own Magic Pants to guarantee success. You'll see that these modules can do a lot more than you think, including accurately timing an Apollo era button press. See you then!